A typical variation question now, they say that fx is two parts. So in your draft, you should know that fx is equal to first part, and then together with another part. There are two different parts affected by x. And then how they are affected? The first part varies as x, that means they are direct variation. So it is k time of x. The second part varies as x squared, that means it's also direct variation. So the second part is kx squared. But however, we have two constants, but they're not necessarily the same. So that's why we give it a code 1 and 2, k1 and k2, to separate two kind of constants. And then after that, they give you the format of the function, and they give you two different cases so that you can log the value of k1 and k2. So in your presentation, you should say that let fx is equal to k1x plus k2x, where k1 and k2 are non-zero constant. Since if it is 0, then it do not vary as x at all. So, and then we given the first case is f3 will equal to 48, and the second case f9 is equal to 198. Because we guess the structure of this function is like this already, we just simply exchange x to 3. So this is k1 times 3 plus k2 times 3 squared, 48. 3k1 plus 9k2 equal to 48. Right hand side, we just do the same. Replace x by 9. So we have k1 times 9 plus k2 times 9 squared. Because it's not simultaneous equation questions, you predicted that there is no method mark for solving the simultaneous equation. So you may just simply use your calculator, first coefficient, second one, third one, fourth, fifth, and sixth input. Then it gives you k1 and k2 respectively. But if you are going to handle by yourself, when I find 3, 9, and 48, I always try to make the number smaller. So if I find that all the numbers can be divisible by 3, I will divide both sides by 3. So k1 plus 3k2, 48 divided by 3 is give you integer 16. Similar here, I realized that 981 and 198 all divisible by 9. So I divide both sides by 9 to get k1. After this simplification, then we already find out the same term k1 and k1. If I copy down, it's k1 plus 3k2 equal to 16, k1 plus 9k2 equal to 22. If I subtract them, k1 minus k1 will disappear, and only one unknown is left. Then we can handle the linear equations. So I try to use this left hand side minus this left hand side. Right hand side is this right hand side minus this right hand side. 9k2 minus 3k2 should equal to 22 minus 16. So k2 is just simply 1 times. Since we know that k1 plus 3k2 is equal to 16, you can choose either one equation, and then I just choose this one because the number is smaller. So k1 plus 3 times 1 is equal to 16. We know that k1 is 13. So don't forget to answer the question. We are not interested in k1 and k2. We need to substitute it back to get the fx. Therefore, fx is equal to k1x, that means 13x, plus k2x, that means plus x squared. That's our answer for part A. In part B, it's so straightforward. They say that we have to solve equation fx equal to 90. You know very well about fx, it's just simply this item. So you just replace it, 13x plus x squared. And you have to find out what is the input to make this item become 90. So you analyze this. we find square here. So this is a quadratic equations. To solve quadratic equations, we have to put everything to one side. So we minus 90 on both sides. And then for these two terms, I just change the order without any changes because it's still in left hand side of the equations. So x squared, how many x? Constant. Then we can use factorization, or you can use your calculator, formula 1, to get the answer of x. That's how we solve quadratic equations. For me, I would prefer using cross method to factorize it. So 90 is equal to 5 times 18. So I know it's minus 5 is x plus 18. Two factor multiply to give 0. That means each factor may equal to 0. So x minus 5 may equal to 0. If not, then x plus 18 will equal to 0. So x equal to 5 or x is equal to negative 18. And then double check carefully because we have two solutions. Is there any constraint for x? Say that if, let's say, did they say that x can be negative, something like that? They don't give any constraint. So we have two solutions. That's our final answer.